I have the privilege of introducing the next speaker. Dr. Eric Bubar is the founding professor of engineering at Marymount University and is dedicated to democratizing engineering education by making it accessible to all through open source hardware and software. He focuses on creating assisted devices using 3D printing and microcontroller electronics, virtual reality rehabilitation games, and AI-driven in-home rehabilitation programs. So please welcome Dr. Eric Bubar.
Thank you very much for that great introduction. I have the honor of actually being invited to speak here, so thank you very much. This talk I want to tell you about how we're training the next generation of engineers for using extended reality, and you can see kind of all the tools that we're trying to use in doing this at Marymount. So I'm going to start with this. Maybe you recognize this meta-human. So I've made myself into a digital person. So there I am. Let's see if I click play. There I am exercising. Something you'll notice about meta-humans, he's a little bit more jacked than I am. Okay? Meta-human, you don't do a 3D scan of your whole body. It's kind of just your face. And you don't get your hair. So I just had to pick some hair that looked a little bit like mine. The balding guy was the closest I could get. So I want to, who was it, who just gave a talk about getting better hair. So I need help with that. I was at one point. Actually, I'll talk about it a little bit later. We have a tool that we can use now to measure how flexible I am with VR. So how do we define extended reality at Marymount? It's basically just merging the physical and the digital worlds. So we're doing augmented reality with computer vision, using webcams, mobile apps, video game systems, immersive headsets with pass-through, so Quest and Vision Pro we're starting to play with a little bit. And then we also do full-on immersive virtual reality, so putting you in the headset and blocking out the entire outside world, which sounds wonderful to do sometimes. So the method to our madness, how do we actually do this? I'm working with mainly undergraduate students, and these are largely underrepresented and kind of underprepared for STEM students. So the way we engage them in STEM is by solving real-world problems. So we try to use these technologies to solve problems that they're interested in solving. In education, we call this project-based learning, but it's basically just projects that students can make an impact on the world by doing. I like video games, I like game systems, so we focus on using gamification. And there's a nice, well-developed framework for how to make games fun. So I can use that to make education fun. Right? Video game companies spend a lot of money figuring out how to make what they do fun so that you buy it. So I just steal all of that knowledge and use it to make education fun. Okay? The MDA framework, MDA stands for Mechanics, Dynamics, and Aesthetics. Those are the kind of three elements that you want to include inside of your games. And it's very well developed. It's kind of a guideline, a map for how to design good educational experiences. We focus on human-centered design. So I do focus my students not so much on the technology. That's what a lot of engineers want to do. I want to use the technology, and they forget about the people that are actually going to use it. So we focus on the person that's going to be the end user. And I, like Blake was saying earlier, I love open source. We try to use open source philosophy. I'm a horrible engineer because I just want to make stuff and give it away. So I don't make money from what I do. I focus a lot on accessible technologies, so I call it COTS, commercial off-the-shelf stuff, Arduinos. So I'm not making my own circuit boards. We're using circuits that we can buy and put together the sensors that we need. Virtual reality, we use a lot of additive manufacturing, a lot of Python, and a lot of standalone VR headsets. Quest 2, Quest 3, Quest Pro. I will talk to you about any of them that you want to talk about and tell you what you should get if you're interested. And then Apple Vision Pro we're starting to play with. We have living training documentation. So that is a Google document. So I just update that periodically. Updated it a couple weeks ago when Meta released some updates to their SDKs. So I found I gave some students an assignment to create some VR stuff in a couple weeks. And I found that Meta released some updates to their system that broke all my documentation. So we had to fix that. That's why it's living documentation, written with and by students as they're learning. And that's what makes this a very challenging field to actually teach. because there are such rapid updates. By the time I develop a curriculum, it's broken. So I just have to constantly update things. And we're teaching our students to deal with that as well. They're like deers in headlights sometimes, but we figure out how to make it work. So some of the clients that we work with, you'll notice a lot of these are Marymount people. I am basically the VR person, the extended reality person at Marymount. We have about 3,000 students, about 150 faculty, and if they want something that involves extended reality, I'm the one there that can do it. So some of the programs we work with are interior design department. I have friends at the American Astronomical Society. Many moons ago, I was an astrophysicist, so I keep some of those connections, and they ask me to do things. Our biomedical engineering students, Enable Global 3D Printed Open Source Prosthetics. Anybody ever heard of Enable in here? Nobody knows? A couple of you, the people that I know it, of course. So they make superhero 3D printed prosthetics for kids and give them away all over the world. So I work with them a lot. Our Marymount University Center for Optimal Aging and Department of Physical Therapy, those are probably my biggest customers, if you can call them that, although Marymount Athletics is a fast-moving competitor. And then also did some private consulting work with Limber Healthcare, all of this on extended reality. Okay, so now the fun stuff. The clients and the projects that we are doing. So our interior design and architecture faculty, let's see, it's July right now. In mid-May, they came to me and said, oh, we want to go to the National Mall and we want to talk about how we can design for aging people. So how can we teach people how to create homes that are good for people as they're getting older? But we can't bring a whole house to the National Mall for this event. Can we make it in VR? Okay, when do you need this by? Well, we need it by June. Okay, so I have 2 weeks to figure this out. Okay, let's do it. So we spun ourselves up, figured out a new software called Revit, and a new software called Enscape, and a new software called, I actually forget the last one because we ended up not using it. So we taught ourselves how to use that, taught our engineering students. You can see that bottom left picture. That's one of our engineering students who learned how to use it. And then you can see the blonde figure in the bottom right, just the eyeball. That is the faculty member that requested it. So that is her learning how to use it from the student. And then the top two pictures with the young lady with the black hair, that is somebody that I've never met. I taught her entirely virtually how to use the VR system to demonstrate and showcase their work. We use the Quest Pro. Quest Pro is probably the best demonstration headset you can get. It is so easy to put on. Anybody can just flip it on over their glasses. It's not hard at all. And we were getting a wide variety of individuals that had never seen VR before, trying this out and viewing these interior designs creations. And really, they were having the goal to be able to see contrast in different surfaces inside of homes, which is very important as you're aging, apparently. And you can't really demonstrate that without actually building it unless you do it in VR. So very useful, very interesting project on the National Mall. Other projects, so we've got the AAS. This was the AAS. Again, people have a trend of coming to me like 2 weeks before they want something and saying, hey, can you do this? And of course, I say, sure, why not? So the AAS came to us and asked us, hey, we're doing this event on Capitol Hill. Bill Nye's going to be there, and you can get a picture with Bill Nye and use it for publicizing your program. But what we want you to do is show off what you're doing with your students for teaching them how to do things related to space. So we showed off a little robotic arm, and we developed something called the Mars Sample Return Rover experience. So this is one of the demos that I have over in the room next door. If anybody wants to try it, you can drive around a little rover on Mars and try to pick up little Mars samples from the surface. So we did this. We developed this with the students, Michelle on the left and Caduce on the right. They helped create this over the span of about a weekend. So the thing that we made, right here, we have a video and a little bit of audio. This is me describing what we'd created as of Friday to the client that wanted it at AAS, giving her some options for what we would finally implement. And then you can see that final implementation if you come play the game. That's my plug to come see my demos.
Here is a proof of concept for the Mars sample return demo. So this is all in VR. I am controlling it with VR controllers. Here we have the Perseverance rover with the Ingenuity helicopter flying along behind it. And we've got audio here. This is audio of the Ingenuity helicopter, actual audio recorded from Mars. And we'll put on some audio of the Perseverance rover when it's actually up and running. And what we can do is we can actually drive, look around, and this is the topographic map of the surface of Mars, Gale Crater, where we currently are, and we can drive around. So I can drive forward, I can turn, we can adjust speeds of all these things. And that hum you hear again, that's the sound of the helicopter and of the rover itself. So I could cruise on over. We have an accelerated speed, and we can drive over and around on craters.
Can't go too fast. You'll launch off the planet
We
if you
can
do.
aim for the big craters in the distance. If you get going really fast, you can launch yourself over a ramp and end up really high up in the air, flying around.
You get some airtime.
And what I'll work on today is maybe texturing a little bit more, or I could gamify this a little bit more so that we have a challenge where you have to do a little like Mario Kart racetrack and have to pick up little Mars sample return canisters so that we can time this and make sure that people don't spend too much time in here exploring Mars, the surface. You can also change where people start off so that they can actually start off in maybe a more interesting region so that there's more for people to look at. And then we'll work on fixing that little issue of tilting over.
Don't think the rover has
But that's
that
what we've got
functionality.
so far.
Okay. So I put this in here for another reason too, right? I'm teaching students how to do this. So it's important for them to kind of think about their clients, and their clients might not know what it's possible to do. So you notice in that narration, I was kind of giving options. These are the things that I could do with this probably in the next day, in the span of when they needed this. So trying to give the client a chance to kind of give some feedback and giving them some idea of what we can actually do. I sometimes forget that people haven't been doing VR for like 10 years. The same problem with 3D printing. We have one sitting in our kitchen, and I forget people don't. This is a baseball pitching simulator that some students wrote. So this is entirely student done. They went from not knowing anything about Unity, how to operate it, that it was even a thing, to installing it, getting the headset up and running, getting developer accounts so that they could run this stuff, and getting hand tracking working. So this is working entirely with hand tracking. And they attempted to make a baseball pitching simulator. You'll see how well it went. They got music in there, and they like this music. So they tried to do some texturing to get some grass in there. The ball that they're throwing is actually a cube, because the tutorials tell you how to do a cube. They couldn't figure out how to get a ball, so they used they're just rendering a ball appearance on top of the cube, picking it up, throwing it, and kind of calculating some kind of velocity. This was a 6-week project that they had to do this. I don't have this set up so that you can demo it, but we have a very more advanced baseball pitching simulator that you can try out, and I'll talk about that a little bit tomorrow. So there's another student project from 3 of our biomedical engineers. Another big aspect of what we do, I make a lot of 3D printed prosthetics, so we're doing virtual training for prosthetics. This is work from a student in 2019. This is her senior research thesis, Catherine Sanchez. She is now a biomedical engineer working at Merck in Virginia. The idea of this was to control a virtual arm with muscle signals. So using EMG sensors, sending that data to Unity, and using that to gamify kind of a muscle training simulation. So we'll show you what she got. She got some decent results. We use the commercial myoband. I think that's it. From all the publicizing that I can see on YouTube for APL, you have your prosthetic limb is all over your website, and the myoband seems to be what you're using. We can't buy that anymore, so we need to find new sensors to use. So we're working on that, working on using multi-sensor fusion, maybe different kind of sensors, and maybe improving connections with Unity, Unreal, and then use AI and machine learning to improve everything, because right, that's the magic word. That's how you get money. Say we're using AI and ML. Okay, so we'll let Catherine tell you what she did.
Is it going?
It's going now. First question. Well, what's your name?
Catherine Sanchez.
Catherine, and where do you work?
I am working here in the lab with Dr. Bubar, doing my honors thesis.
Yeah.
And
What's your thesis topic?
my thesis topic is working with myoelectric prosthesis, and specifically focusing on like the rehabilitory training, and making it more into a game and making it easier for training and connection to the myoelectric prosthetic.
Okay. So what do you have on your arm?
So I have a myoelectric armband right now.
Okay.
And there are sensors on each of these little blocks that read the like electric waves that my muscles are producing. And they connect to a Bluetooth chip in my laptop.
Okay.
Yes.
And then what does that do?
So I've been working on connecting it to a virtual hand, which I have here, and it's taking a lot of time. And I have certain gestures that are connected to poses that I will make with my hand and demonstrate.
Okay, let's see.
Okay, so fist, and it hesitates some, but I'll figure out how to fix that. And then back to idle, and then when I wave in, it gestures, and back to idle, and wave out is a pick, and back to idle. And that was a fist, but I'm gonna fix that, that's okay. Okay, and back to idle. Yeah, so that's what I've gotten so far. It's taken a lot of time.
Perfect. How awesome is that?
I'm so excited.
Fist bump.
Yes, and virtual
fist.
Yes.
So she took about 3 months to learn Unity and how to make the Myo armband communicate with Unity and send those signals. The poses she's doing are the ones that were programmed into the Myo band by default. So we're working on using different EMG sensors to kind of customize that a little bit more. Then the last kind of big project that we're really working on is using AI to do exercise. This is 2 students have been the real guides behind this, Ainur and Jenna. Actually, Jenna's in the audience. Jenna, raise your hand. So if you have questions about this, go ask her. If anything goes wrong, then it's her fault. Jenna is starting as a DPT student, and she just graduated with their BS in health professions. Health sciences, okay. And we've also done some of this work with Limber Healthcare. So what this is using extended reality with open computer vision, pose recognition. We're using algorithms from Google called Blaze Pose. So this little this little stick figure that you see over here has key points that are identified on the body. Blaze Pose can automatically identify those in images when you feed it to them, or through a webcam, through a live webcam. Blaze Pose is nice because it's trained and designed to operate on low resource kind of computing. So you can run this on a cell phone. You don't need a big, really power intensive computer. We're gamifying common exercises for falls prevention. There's a program called the Otago Prevention Program from University of North Carolina, at Chapel Hill. And we're training the system to recognize when people are doing these exercises. We're training based on conditional statements, so if, then, that kind of stuff, and also trying to develop some machine learning models to recognize these poses as well. We have some ideas on how to improve this, training more robust models with more people, or because I like sitting in the basement and hiding from people, trying to create synthetic humans. So maybe some of my little Unreal Meta Bubars, we can train those. To be our data samples. So again, I want to gamify this stuff. So we've created, on the left-hand side, you can see the webcam actually identifying those key points on my body. And as I start moving and exercising, I'll be controlling Pac-Man. So I do shoulder flexion, shoulder abduction, squats, different exercise motions that are really useful for aging people to prevent falls, to control where Pac-Man is moving. Very intuitive, very easy to pick up. We want to kind of use classic kind of video games that are really easy to control. We don't want somebody trying to play Call of Duty with us, especially somebody that's susceptible to falls. That would probably be a bad idea. We can play Tetris as well. I'll have a demo set up next door, so you can try this. You can try to play Tetris if you want. It's just sped up a little bit. You can work up quite a sweat playing Tetris just by doing these tiny little moves. It's harder than you think. And if you notice, this is being filmed in a hotel room because that's where you do your best work, right before you got to present at a conference. Here's the Otago exercise program. Here we're using machine learning to recognize poses. And you see it does a pretty good job, depending on the threshold that we set for recognition. And then here's some work to use the system to recognize center of gravity and margin of stability to kind of tell if people are walking around, if they're susceptible to a fall. So if I start leaning over or away from my center of gravity, it can kind of tell me if I'm going to fall or not. So we're working on all of these things and working on developing and improving them, working on getting a better UI for all of this so that it's easier for clinicians to use. We presented this at the ACSM American Congress on Sports Medicine. I showed this to them and I was like, this is so exciting, this is so cool. We can do this thing called the best test that they have to stand there and take some time to do, and we can do it all automatically. They didn't care. They're afraid AI is going to take their jobs. But here, we can show you what we've got. So we've got a whole system that they can gather data. They can pick poses. Now this is showing the video. And as I walk back, you'll see it's going to say no pose detected, but it is giving different percentages for the likelihood that that is one of the poses that you're finding, that it would find. Double leg stance. Again, we're getting about 50% probability. We need to improve that. Jen and I are actively working on that. And then we also have a baseball training simulator that we are working on. This is to do baseball pitching drills with the Meta Quest 3 inside-out body tracking. I think it was updated in June, so this is about a month of work to get their latest and greatest stuff up and running. If you want to try that out or want to hear more about it, you got to come on day 2. Or if you're not going to be here on day 2 and you really want to try it, I did bring it so you can try it over in the demo room. Okay, we can also use this for assessing range of motion, so I can figure out if I really am as flexible as my meta-human, which I'm doubtful. If there are any questions, I think we have about 5 minutes for questions. I timed that pretty good. You'd think I taught. I think they'd like microphones for questions, if you don't mind.
Hi, just wanted to double check which library were you using for your pose estimation? Was it just using a webcam? You weren't using any depth sensors, it was just an image?
It's just a webcam. So what Blaze Pose does, it has the 2D point recognition X and Y positions on the camera image. And then it uses something called GUM, which is a 3D body algorithm that can estimate what the depth is based on the X and Y position. So we can get X, Y, and kind of Z depth of all the poses.
You said it was called Blaze Pose?
Blaze Pose.
Blaze Pose.
Yeah, Google Media Pipes Blaze Pose. All freely available.
Awesome. Okay, thank you.
Yeah.
Hi, Mitzi Herrera from Montgomery County. This summer, we piloted in the winter, but we just launched a VR seniors project. So we have 80 Meta Quest 2 headsets deployed in senior centers. So one question I had is the Mars rover, is that available someplace for people to use?
I can make it available.
Okay.
Yeah, just come talk to me and we can get it to you. We can get you an APK.
Great. And then the second thing is just, I'm curious on the baseball training. We noticed we're trying to move towards moving more of the hand controls, but does it really work well considering that you have some odd, you know, if you pick up an object, it's not just like you pick it up normally because the device recognizes certain things.
Right.
So when you do the baseball VR training, is that actually using a real pitching motion and the hand, or is it you've got the arm is correct, but the hand is not?
It's a fantastic question. I want to say wait till tomorrow and I'll answer it, but no. So We've experimented with the baseball training to just use hand tracking, and it's just not accurate enough. The hand tracking can't track the arm at the speeds that you're going to get a good pitching motion. So we do need to use the controllers for that, and that increases the accuracy of the tracking. And then it's all based on a switch in pushing the buttons and animation of the hands to get that kind of reaction. We are working on a peripheral that is a baseball. If you stop by the table, I can show you it. It's got an IMU embedded in it, and that's sending information to the VR headset so that we can get that real natural pitching motion, get the actual pitching activity, get that to show up in VR. That's what our baseball coach wants, and I'm trying to deliver for him.
Cool. All right, and then the last question is, so we've been immersed in looking at new applications and things. When you go to a lot of these things, people talk a lot about these things for seniors, social isolation, a lot of different new memory type of therapy or exercises. But one of the things that we're finding is that there's not a lot of the metaverse that's created for older adults or that's particularly welcoming for older adults. And so I just wanted to know, have you, in what you've been coming across, found some things that you thought were better suited or things to look at? Tips?
That's another excellent point. I have not found anything that's good. Actually, I don't think that a lot of what's created for the metaverse is good for just general people. It's good for XR enthusiasts and people like all of us. It's not good for a general audience. What works for me, I think, is I can force my mother to do this because I tell her, I need you to do this to test this out for me. So that gets her into it. And then she has some benefits that she gets out of that. So my mother, she has Parkinson's. I've read some studies that Parkinson's can benefit from getting lots of visual feedback, auditory feedback, and things that challenging them to use both their arms. There's a VR game called Beat Saber. So I call her up periodically and say, Mom, did you play your Beat Saber today? Because when she plays it, it kind of shorts her brain out and her tremors get mitigated by that activity. That can help with kind of staving off some cognitive decline as well. It's the same mechanisms. But getting people to do that, especially older people, I think one of the most successful anecdotal approaches I've heard is get the grandkids, get their children to say, hey, will you play this with me? Will you try this out with me? And then that's how you get them in. But yeah, they're really, I think it would be useful to develop a good kind of UI that's friendly for older adults.
All right, thank you.
Yeah. Happy to talk more. Come get my card. Thank you.
All right, thank you, Dr. Eric Bubar. Please give us a minute.